Hello students, today I am going to discuss about pp and pp bonding. Okay, what do you mean by pp? Now pp bond form, pp bond form, pp and pp bond. This is formed at a form by overlap between two p orbitals. Okay, overlap between two p orbitals. Okay, the two p orbital overlap है pi bond formations. Okay, this is p pi, but the overlap must be the lateral overlap, and p pi d pi d pi bond is formed by overlap between p orbital, p and d, right? Very simple. बोलना जे p pi bond formations have by overlap between two p orbital. Of course, the formations of pi bond, the overlap will be the lateral overlap, not the head-on overlap, right? That will give you the pi bond formations. Now, if I give you some example of p pi, these p pi is very common. P pi bond is very common. We have lots of examples of p pi bond. Okay, let me show you first the p pi bond, some examples. Okay, if you like take the examples of ethylene, what will happen? This is sigma 1 beta. Okay, it has sigma 1, no problem. It has sigma 1. Now how about this one? This is of course pi bond. Pi bond formations. Pi bond formations will be like, say this is pz. Say this is pz. So pz sideways overlap. So that will give you the pi bond. So this pi bond is basically p pi point. Okay, this is p pi bond. Like here p pi will be, it looks like, come on देखते हैं बेटा, plus minus. So it looks like this will be the nucleus. এখানে দিয়ে দিলাম positive, এখানে negative. So this is p pi bond. Okay, no problem. This is p pi bond. Okay, this is plus, this is minus, this is minus. This is p pi bond. In case of acetylene also, if you take the example of acetylene, let me show you the example of acetylene. In acetylene, what will happen? See, one bond is sigma 1. This is formed by overlap of sp orbital. Another two bonds. This is beta p pi, and one more, say pz. Say this is pz. So this is also p pi. No problem. Clear? These are the examples of p pi bonds. Now, how about p pi d pi bond? You will be given lots of molecules. Say you will be given one molecule, and on that molecule, maybe there will be both p pi and p pi d pi. So how to know how many numbers of p pi and how many numbers of p pi d pi bonds are present? So I will discuss the number of p pi and p pi d pi bond for all these molecules. Okay, so let me show you. Let me start with SO2. Okay, let me start with SO2. Okay, before I discuss about the p pi d pi and p pi bond in SO2, let me show you how p pi and d pi bond formations takes place. p pi bond হবে কি করে? ওকে, p pi bond হওয়ার জন্য বেটা p pi d pi bond কি করে formations হবে দেখা যাক। ওকে, say this is p orbital, this is plus, this is minus, no problem. Okay, d orbital. Okay, say this is d orbital, this is d orbital, problem. Okay, this is plus, this is plus, this is minus, this is minus. That's all done. This is beta d pi p pi. This is d pi p pi. Here this is d orbital and this is p orbital. And remember one thing, that these d orbitals are basically dxy or dxz or dyz. Because in this case, the orbit, you just look at here. Simple, you just look at here. See, if I show you the p pi and d pi bond formations, how does it form? See, if you look at here, can you see? See, this is d orbital. Lobes are beta along the axis. Lobes are beta along the axis. So overlap will be like this. Overlap will be. Can you see? Can you see? Can you see? Okay, let me. Okay. Can you see that? This is p pi d pi bond. This is p pi d pi bond. I think you can see it clearly. Okay, p pi d pi bond. And if you want to see the p pi bond, so this is p pi bond. This is beta p pi bond. Okay, sideways lateral overlap, sideways overlap, not head on overlap. That will give you the sigma bond. This is basically pi bond. Okay, done. Now next move to the molecules. Okay, SO2 molecule, let me show you the examples of SO2. Okay, in SO2 molecule, how many numbers of p pi and p pi d pi bonds are present? See, in order to do so, in order to know that, first our target is, job is to know the hybridizations. If you know the hybridizations without doing much calculations, okay, you can easily tell how many numbers of p pi and how many numbers of p pi d pi bonds are present. First, I will show you 2-3 molecules, the detailed explanations, and after that, rest of the molecules you can do in no time. Okay, so okay, first you just calculate. Better you just calculate hybridizations. Okay, we'll calculate first hybridizations. Or else you just do one thing, or else you could do the Lewis structure. Okay, Lewis structure. If you are able to draw the Lewis structure, from that Lewis structure we can easily count the sigma and pi bond, and from that also we can easily tell that number of p pi and d pi bonds. Okay, so how we can do that? Okay, so SO2, first what we will do, we will calculate the hybridizations. In order to know the hybridizations, beta, what we do? Total valence electron we will calculate. So total valence electron, how many? 6 plus 12, that is basically beta 18. So you just divide it by 8. 8 2s are 16. 2 1 2. Okay, string number 3. So string number beta 3. If string number is 3, then hybridizations is sp2. Okay, so hybridizations is sp2. Done. See, from the sp2 hybridizations, we can say that how many numbers of p pi and d pi bonds are present. That we can easily tell. That you will be able to do it after some period of time. Okay. And one more interesting thing, you need to draw the Lewis structure. Lewis structure জানতে হবে. Lewis structure যদি জানি তাহলেও কিন্তু Lewis structure থেকে we can easily calculate the number of p pi and d pi bonds. Okay, Lewis structure, how we can calculate? Lewis structure, in order to do the Lewis structure, we must know the lone pair of electron, then sigma bond, then pi bond. Okay, that many informations we must get. So in case of SO2, how many sigma bond? Already I have discussed in my Lewis structure video. Please go through that. Okay, sigma bond here beta কতগুলো? Number of atoms. So So 3 minus 1, that will be 2. Okay, that will give you sigma 1. Okay, lone pair of electron. Lone pair of electron, beta. How many? Okay, total valence electron 18. 18 minus 80 into number of bonded atom. 8 into 2 divided by 2. So lone pair will be 1. And pi bonds, total bonds, the formula will be total valence electron. For sulfur is the central atom, so valence electron 6 minus lone pair of electron 2, so 4, so total bond 4, so pi bond equal to 2. Okay, we have got all the informations. Okay, from here now we can draw the Lewis structure. From here we can draw the Lewis structure. Beta দেখো ভাই এখানে সিগমা বন্ড আমার 2 জানা হয়ে গেছে, পাই বন্ড 2 জানা হয়ে গেছে, লোন পেয়ার 1 ডান, all the informations we have got. Okay, got it? In order to draw the Lewis structure আগে অনেক একটা ভিডিও বানিয়েছি, প্লিজ গো থ্রু দ্যাট ভিডিও. ওকে, ওই ভিডিওগুলো দেখো বুঝতে পারবে. ওকে, all the informations I have got like 2 to 1. Now I am going to draw the Lewis structure, then I will show you the number of p pi and p pi bond. Okay, চলো বেটা. So SO2 তে SO2 structure draw করা যাক. Let me draw the structure of SO2. বেটা SO2 central atom is 2 sigma, 1 sigma, 1 sigma, 1 lone pair of electron, 1 pi, 1 pi. Done. This is the Lewis structure. Okay. Now hybridizations here. How many numbers? Now next job is how many? Okay. Sulfur is sp2 hybridized. Let me write that. Beta sulfur is sp2 hybridized. Hello. Very simple. Very simple. sp2 hybridized. Okay. Therefore, now I am going to see whether this is p pi or this is p pi d pi, or both are p pi or both are d pi. Okay. How can we do that? Okay. First, let me show you the detailed explanations. Okay, sulfur. Let me show you the sulfur hybridizations. Okay, let me. Okay, sulfur electronic configurations. প্রথমে sulfur electronic configurations বেটা লিখি. Sulfur electronic configurations. 3s2 3p4. 3s2 3p. Right. Okay. How many unpaired electrons are required? 1, 2, 3, 4 unpaired electrons required. So there are not 4 unpaired, 2 unpaired electrons. So sulfur will be excited and the configurations will be 1, 2, 3 and one more electron will come to D. This is D, this is beta P, this is 3D and this is 3S. Okay, done. So hybridizations will be sp2. So let me show you the hybridizations sp2. So 2, 3, 4, 1p electron and 1d electron. This is 3sp2. Okay. Now you just look at here. ভালো করে দেখো এটা এখানে এটা lone pair of electron. See. এটা lone pair of electron. Done. Oxygen electronic configurations. Let me write that. Where I can. Okay, I write it here. 2s2, 2p4. Okay, no problem. So this oxygen p orbital and this hybridized orbital will form the sigma bond. Okay, oxygen 1. This is say oxygen 1. This one will be used for sigma bond. So this is sigma bond oxygen. Say this is for this oxygen, and this is oxygen number 1. This is oxygen number 1. It's okay. Oxygen number 2. So oxygen number 2. This is say oxygen number 1. Oxygen number 2. What will happen? In oxygen number 2, one unpaired electron is there. So this one also give you the sigma bond. So this is 1 sigma and 1 sigma. Done. Now if you look at the electronic configurations of oxygen, see one will be used for sigma. O2. Let me write also O2 2, 3 and 4. One will be used for sigma. So this is sigma and this will be used also sigma. This will form the pi. So how that pi bond will formations takes place? See, this p orbital and this oxygen p orbital will form p pi, right? And this one Okay, let me take a different color. Okay, this one and this one will form beta p pi d pi. Clear? It's very simple. Acha? Very simple. So p pi d pi, this one sigma bond, this is sigma bond. One will be p pi and another will be p pi d pi. So one will be p pi and another will be d pi. So in SO2, one p pi and one p pi d pi. Done. So hybridization is sp2 and we have got one p pi and another d pi. Now p pi d pi or p pi this bond, either it will be p pi because there will be resonance. Okay, so no need to write here p pi d pi or here p pi. If you write here p pi or here p pi d pi, that doesn't matter because there will be resonance. So this bond might be p pi d pi or p pi or this bond might be p pi or p pi d pi. Okay, what I am trying to say, that there will be only two pi bonds, and pi out of two pi bonds, one will be p pi beta and another will be p pi d pi. Which one will be p pi d pi, that don't mention. Okay, so one p pi and one p pi d pi. Right. Now next move to SO3. Okay, it's clear? Acha? Chalo. Next move to SO3. Next move to SO3. কি বলেছি? SO3 করতে গেলে কি হবে? Lewis structure draw করতে হবে. Before Lewis structure we check the hybridizations. Hybridizations কি হবে ভাই? 6 plus 18 24. 24 means 8 divided by 3. Static number will be 3. Hybridizations will be sp2. Done. Lewis structure, you please go through my video. Lewis structure, sigma bonds will be 3 4 4 minus 1 4 minus 1 3. See, lone pair of electron 0 and pi bonds, you just calculate pi bonds equal to total bonds will be 6, so pi bond will be 6 minus 3 is equal to 3. Done. These are the informations about SO3. Now let me draw the structure of SO3. So structure of SO3, okay, let me draw the structure of SO3. Okay, I'll take this one. S double bonded O, double bonded O, double bonded O. Let me write everything. Okay, so this is the hybridizations, that is sp2. If it is sp2 hybridizations, then how many numbers of p pi d pi and p pi bonds are present? Very simple. How can we say that? See, if the hybridization is sp2, then okay, can I first okay, if the hybridization is beta sp2 means, let me show you that. So there will be no one pair electron. Okay, 1 2 3 4 5 6. Okay, so this is beta 3s, this is 3s, this is 3p, this is 3d. This is 3s, 3p and 3d. Now see, hybridization is sp3. So these three electron, hybridization is sp2. Okay, hybridization is sp2. Oh, sorry. Hybridization is sp2. So these three electrons will be used for sigma bond formations. Now pi bond. See how many p electron and d electrons are present. See, one p electron is present. So this electron will overlap with oxygen unpaired electron. So this will give you, see, overlap of oxygen unpaired electron. This is p pi d pi. So this is p pi d pi. Okay. See, in this case also like overlap with, this will be say d pi p pi. It could be anything. It could be also d pi p pi. That doesn't matter. This is okay, d pi p pi. Done. So how many numbers of p pi d pi and p pi p pi? How many numbers of p pi p pi and d pi p pi? That number is basically, so here I will write. Here I will write. See, p pi p pi 1 and p pi d pi 2. That's all done. This is the p pi d pi and p pi bond for SO3. Now go to SO F2Cl2. Now let me tell you now one thing. Now let me show you the important trick. What is the trick? Now I am going to show you the trick. Instead of I'm going to detail a thorough discussions of hybridizations. We can, from the structure we can easily tell. That I am going to now discuss. Okay, if the central atom hybridizations is say sp2, that means beta 2 hybridized orbital will be used for, say like this, 2 hybridized orbital will be used for sigma bond formations, and one hybridized orbital. This will be used for say one electron is there. So this will be p pi, and this will be p pi. What I am trying to say, that if the hybridization is sp2, there will be one p pi, at least one p pi. At least means here better I will write, there will be one p pi, must one p pi. Hybridization is sp2, and if two pi bonds are there, then another will be p pi. Okay, so if hybridization is sp2, then one will be p pi, because this p orbital will be used for sigma bond, and this p orbital basically for pi bond formations. So hybridization is sp2, then p pi, one p pi must be present, and another will be p pi d pi. You got done? If hybridization is beta sp3, now look at carefully. If hybridization is say sp3, so sp3 means central atom 1s and 3p will be used. This will be used for hybridization sp3. And d orbital, say d orbital electrons are like this. So this d orbital, okay, there must be some electron. I am putting electron here. Okay, say like that. So in this case, all the bond will be pi bond. Pi bonds will be d pi p pi. Okay. So if sp3 hybridized, the central atom is sp3 hybridized, যদি central atom sp3 hybridized হয় তাহলে ওখানে কোনো p pi বন্ড থাকবে না। ওকে, যদি সেন্ট্রাল অ্যাটম ভাই sp3d হয়, সি sp3d means what? সেন্ট্রাল অ্যাটমে প্রত্যেকটা p অরবিটাল ইউজ হয়ে গেছে। In that hybridizations there won't be no p pi, কোনো p pi থাকবে না, যা থাকবে d pi, whatever pi bonds are present, that will be d pi. If central atom is sp3d2, then also no p pi, only d pi. No. If hybridization is sp3d3, then also no p pi. No p pi. And hybridizations, and all will be d pi. Okay. If hybridization is beta, is sp2, there must be one p pi. And if one more pi bond will be there, then that will be d pi. Okay. If central atom hybridized is sp3, no p pi. If sp hybridizations, then 2 p pi. If there will be pi bonds, then that will be 2 p pi. There won't be any. After that, some d pi bonds will be there. At least 2 p pi bond will be there. So sp3d hybridizations, all the p orbital of central atom will be used. So no p pi. So all will be d pi. sp3d2, no p pi, because sp3 d pi. sp3d3, no p pi, d pi. sp2, at least one p pi will be there. sp3, no p pi. sp2 p pi will be there. After that, d pi will be added. Okay. Now I will directly draw the Lewis structure, and then from that counting I will show the hybridizations, and I will tell you the number of pi to pi bonds. Okay. SOF2Cl2. See, structure of SOF2Cl2 will be sulfur central. Okay, sulfur central. Fluorine, one bond. This H, one bond. Cl also form one bond. This Cl also form one bond. Oxygen bivalent, it will form two bonds. Okay, this is the structure. From that structure, from 2, 4, 6, 2, 4, 6, 2, 4, 6, 2, 4, 6. Okay, done. 2, 4. This is the structure. You just know the Lewis structure, how I actually taught you, how the way I taught you in my earlier videos. Okay, sulfur is happy. See, sulfur 1, 2, 3, 4, 5, 6 electron use. Okay, this is the Lewis structure. I won't go into the details of that. Okay, hybridization. What will be the hybridization? Count the sigma bond. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Pi bond has no role in hybridizations. So hybridizations is beta here. What? Hybridizations is beta sp3d. Hybridizations is sp3d. If hybridizations is sp3d, and then sulfur will use all its p electron. I will show you only this one. Okay, sulfur. See, total 6 electrons are required for 6 bonds. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, and d orbital. This is d orbital type 6. This is 3d. Okay, and this is 3d. This is 3d. Hybridizations what? sp3d. Okay, sp3d. So if hybridization is sp3d, sulfur can able to form the pi bond because all the p orbital are used for sp3d hybridizations. So that will be used for sigma bond. So this will be left. This is only left. This is only left. So this will be used for pi bond by overlapping with oxygen p orbital and sulfur d orbital. That will give you the pi bond. So how many numbers of pi? Only one. One pi. That's all done. Finish. Now next move to SNF3. See, structure I will directly draw. You just later. SNF3. See, fluorine is happy with 1 and sulfur by nitrogen 3. Okay, 2, 4, 6, 2, 4, 6, 2, 4, 6. Okay, this is the SNF3. So what will be the hybridizations? Beta hybridizations will be 1, 2, 3, 4. 1, 2, 3, 4. So 4 sigma. Hybridizations is beta. Hybridizations is sp3. So these two pi bond will be beta d pi p pi. So 2 d pi p pi, right? Clear? All the bonds are d pi p pi. Because sulfur, see, sp3 hybridizations means it's like that. 1, 2, 3, 4, 5, 6, like that. Okay. So what will sulfur will use? So sulfur is sp3 hybridized. 1, 2, 3, 4. sp3 hybridized. So d pi, this is d, this is 3d. So d pi, nitrogen 1p, d pi p pi, and another one d pi p pi. Done. So 2 d pi. Okay, HCO3. Let me directly draw the structure of HCO3. See, this is Hg. Okay, O3. Okay. Okay, double bonded O, and one more lone pair. So what is the hybridizations? Beta? Hybridizations 1, 2, 3, 4. So hybridizations is sp3. So all the bonds will be d pi p pi. So this one d pi p pi. This one d pi p pi. This one d pi p pi. So 3 d pi p pi bonds are present. Done. HgO4. Okay, let me show you HgO4. Okay. So HgO4 structure. Let me draw the structure. HgO4. Hg double bonded O. Hybridizations sigma bond 1, 2, 3, 4. So 4 means static number 4 means hybridization is beta sp3. So all are, I will write here, all are basically dipy bonds. So all are dipy. 1, 2, 3, 4. So 4 dipy bonds are present. But all are dipy bonds. Okay. Now next move to XzO2F2. Okay. Let me draw the structure of XzO2F2. See, in case of XzO2F2, let me first count total electron. So total valence electron. What? 8 plus 12 plus 14. So 2 is 34. So divided by 8. 8 4 32. 2 is 1 or 2. So 4. Static number 5. Hybridization is sp3d. Now let me draw the structure. So 4 one pair, and 4 sigma one pair and 1 lone pair. 4 sigma one pair and 1 lone pair. Let me draw the structure. XzO2F2. Okay. XzO2F2. Xz 1 lone pair. Okay. XzO2F2. Okay. Okay. XC square. Okay. 8, 2, 6 are 12. 34. Okay. XzO2F2. Done. Okay, this is the structure for XzO2F2. Now, how many sigma bonds are there? Say, from here you can count. How many sigma bonds are there? 4 sigma 1 by 4 sigma 1 lone pair. 1, 2, 3, 4 and 1 lone pair. So, hybridizations here sp3d. If it's hybridizations sp3d means no ppi. See, this is dipy. This is also dipy. So 2 dipy. Okay, done. XzO2F2. XzOF4. Okay, let me show you XzOF4. How I will do that? Total valence electron. Calculate total valence electron. See, 8 plus 6 plus 4, 18, 28. Okay. Okay. Here hybridizations will be 8, 6, okay. Hybridizations will be sp3d2. Hybridizations is sp3d2. Let me draw the structure of shape of XzOF4. XzF4. F double bonded O and 1 lone pair. Count 8 electron. 1, 2, 3, 4, 5, 6, 7, 8. Done. So hybridizations is, what is the hybridizations? Hybridizations beta sp3d2, right? sp3d2. So this pi bond is basically dipy. This is dipy. Okay. Now you go to XzOF2. Total valence electron 8 plus 6 plus 2 multiplied by 7. So 14 plus 14, 28. 8, 3 is 24. 4, 2, 2 is 4. 5. Static number 5. Static number 5 means sp3d hybridizations. Okay, this is sp3d hybridizations. Okay, sp3d hybridizations means no ppi. Okay, XzOF2. Let me draw the structure for XzOF2. Okay, this is Xc, this is lone pair, this is lone pair, this is double bonded O, this is F, this is F. Okay, this is basically a T-shape. Okay, whatever. This is the shape. Okay, T-shape. Okay, structure. Okay, 1, 2, 3, 4, 5. Okay, 3, 2. Okay, so 3 sigma 1, 2 lone pair. So this bond will be beta dipy pi. Done. Now next, go to SO4 minus 2. SO4 minus 2, you just do by yourself. I'll just directly go to the structure. SO4 minus 2 is double bonded O, double bonded O. SO4 minus 2 minus 2 4 2 4 2 4 6 2 4 6. Okay, hybridizations. Okay, go to hybridizations. 1 2 3 4 sigma. So hybridizations sp3. So d pi p pi. So which two are d pi p pi? This is also. So d pi p pi. So this is p orbital electron for oxygen. This is from sulfur. Done. So do 2 d pi p pi. 2 d pi p pi. Done. PO4 minus 3. PO4 minus 3. Double bonded O. Single bond O. This is the PO4 minus 3. So this is the PO4 minus 3. Hybridizations 1 2 3 4. Hybridizations is sp3. Let me write hybridizations is sp3. If hybridizations is sp3, then this bond is d pi p pi. D pi p pi. Done. Okay. Now NO2 plus. One interesting thing I will tell you that without calculating anything. See NO2 plus, NO2 minus, NO3 minus, N2O, OCN, CO3. There won't be any d pi p pi bond. There won't be any d pi p pi bonds. There won't be any d pi p pi bonds. Cano. For what? Why? See, carbon, nitrogen. Okay. See, carbon. See, beta. Carbon, nitrogen. They don't have lower energy d orbital. Lower energy d orbital. If there won't be lower energy d orbital, then promotions of electron, it won't go to d orbital. कार्बन नाइट्रोजन যদি d orbital না থাকে তো 2s and 2p there won't be any 2d. Okay, it cannot jump to 3d. Okay, so if there won't be any lower energy d orbital, that means there is no chance of formations of d pi p pi. I'll show you the structure from that. See, don't get confused that NO2 minus, how will be the structure? NO2 minus, this is the structure for NO2. 2 4 6 NO2. So this bond will be p pi because nitrogen is the element of second period element. They won't have any d orbital, lower energy d orbital. So this is p pi. So bond করে লিখে দাও p pi. Okay, বুঝে আছে? Very good. Okay. Next. So likewise, like NO2 plus, NO2 minus also, NO2 plus also like that. Okay, NO3 minus like that. NO3 minus. Let me show you. Okay, NO3 minus. Okay, structure I won't draw. I won't draw the structure. Okay, you just do it by yourself. Okay. So there will be no d pi p pi, right? Okay, done. Now next move to ClO4 minus. What will be the structure for ClO4 minus? Okay, let me draw the straightforward structure. You just do by yourself. ClO4 minus. Double bonded. Okay, put the electron here. 2 4 6 negative formal charge. Put here. Done. So okay, hybridizations 1 2 3 4. So sp3 means this pi bond basically d pi p pi. This pi bond d pi p pi. Okay, d pi p pi. Done. All the p orbital of chlorine is used for sp3 hybridizations. So there won't be any electron left over in p orbital which can form the d pi p pi, p pi bond. So this is d pi p pi. But ClO3. Now let's move to ClO3. Okay. ClO3. What is the structure of ClO3? Double bonded. Okay. This is the one pair of electron. This is also hybridized, used for hybridizations. So okay, count 1 2 3 4 hybridizations. sp3 means this one and this one beta d pi d pi. Done? No problem. Can you do it by yourself? Okay, I'll just help you. I'll show you. Cl 3s2 3p 5 Cl excited. Okay, one electron. This is lone pair. Okay, 1 2 3. Okay, 1 2. Done. 7. 1 2 3 4 5 6 7. Done. So hybridizations sp3 1 2 3 4 hybridizations sp3 done. sp3 no p electron. So this is d pi. So this will give you d pi p pi, and this one also give you d pi p pi. Done. ClO3 done. Okay, OCl minus central atom nitrogen N2O. No need to bother about. Still I am showing the structure. Just a minute. N2O, N triple bond 8, N O minus. This is plus. Okay, 2 4 6 2 4 6 2 4 6 beta 2. Okay, nitrogen is second period element 2s2p. No d, no 3d. So no d pi p pi. This is p pi p pi. Chok bond 2 p pi p pi. Don't worry about the things. Okay, CO3 minus also same. OCN. Okay, if you want to see the structure of OCN, let me draw the structure of OCN. Okay, OCN C double bond 8 O N minus 2 4. Okay, 2 4. Carbon is sp hybridized, and it has no lone d orbital. So this one and this one p pi p pi p pi p pi. Okay, done. P pi p pi. Okay, one interesting example is hexafluorocyclic phosphagene. You just look at this example very carefully, and I will show you the number of p pi and d pi p pi bond here. Hexafluorocyclic phosphagene. What will be the structure of hexafluorocyclic phosphagenes? Let me draw the structure first. Hexafluorocyclic phosphagene. Okay, P N P N P N. Okay. Now alternate double bond you just put. Single bond, double bond, single bond, double bond, single bond, double bond. Now you just put 2 Cl over here. 2 Cl with phosphorus. So Cl done. And lone pair. Okay. Lone pair. Electron here. So this is the structure for hexafluorocyclic phosphagene. 1 2 3 4 5 6 hexafluorocyclic phosphagene. Now from that structure you need to say how many numbers of d pi p pi or p pi p pi bonds are present. Very simple. First go to the hybridizations. Check the hybridizations. Hybridizations what? This is 1 2 3 4 sigma hybridizations sp3. So phosphorus is sp3. This is sp3. Don't bother about nitrogen. I have already mentioned. So this is also sp3. So 1 2 3 4 sp3 1 2 3 4. Okay, 1 2 3 4. Sorry, 1 2 3 4 sp3 means this pi bond. Say this is the pi bond d pi p pi. Any doubt? ঠিক আছে বুঝে যাচ্ছে বেটা আরে ভাই বুঝতে পারছো d pi p pi. This is also d pi p pi. Done. So like that way you can do the calculations or number for p pi and p pi d pi bond. যে কোনো ভাবে করা যায়, খুব সিম্পল। এই স্ট্রাকচার করা করলে মোর দ্যান সাফিসিয়েন্ট। বাকিগুলো যদি থাকে নিজে করে নাও। এই স্ট্রাকচারগুলো একটু প্লিজ পে অ্যাটেনশন অন দিস স্ট্রাকচারস। ঠিক আছে, এগুলো করে নাও। জাস্ট let me before finish I'll tell you one thing that so conclusions what conclusions. So in order to know the number of p pi and p pi d pi bond, how to? Okay, I just check the hybridizations, then or else Lewis structure. Okay, see Lewis structure if I know, then from that hybridizations we can easily get. Okay, hybridizations. Okay, hybridizations sp3 d sp3 d2 sp3 d3. Okay, correct. No d pi p pi bond. Sorry, no p pi p pi bond. No p pi p pi bonds, beta. No p pi p pi bonds. Okay, there won't be no p pi p pi bonds if hybridization is sp3. If hybridization is sp2 at least one p pi p pi. If there is pi bond, at least one p pi p pi. Okay, done. So like that way you just calculate. So thank you so much. You just do by yourself the structure. You just please try to do it by yourself. If you face any difficulties, you just write me. Okay, thank you so much.